In this video, we're going to look at the internals of ASP.NET. We're going to talk first of all about how ASP 3.0 worked, and we'll compare that to how ASP.NET works. And then we're going to look at why ASP.NET is faster than ASP 3.0 and why it's actually a better programming model for developers. And then later on in the video, I'll show you why and how when you create an ASPX page, what happens behind the scenes the very first time it's run. So first we'll start by talking about ASP 3.0 and how it worked with IIS. In ASP 3.0, the ASP processor was implemented as an ISAPI extension, and ISAPI stands for Internet Server Application Programming Interface. And basically, ISAPI is a programming interface that developers can use to extend the functionality of IIS. The ASP.dll is simply a COM object that supports specific interfaces and types in order to be an ISAPI extension. So you can create your own ISAPI extensions if you know C++. ISAPI extensions are associated in IIS with certain file types. And for ASP, or the .asp file extension, it would look it up in the metabase and find out what type of ISAPI extension handles the ASP request, and it would determine that the ASP.dll is what handles it. And so when IIS receives an HTTP request, it looks in the metabase, figures out that it needs to load the ASP.dll, and then the ASP.dll kind of manages it from there. It's responsible for basically looking up the file name and loading it and parsing it. And if there's already a cached template of that ASP file, then it loads that instead and parses it. And then it has to call the appropriate scripting engine based on what the directive at the top of the page is. So remember how you used to have language equal VBScript or language equal JScript. It loaded the appropriate DLL that had all of the logic to perform the logic in your ASP file, and then it performed all that logic and then sends the results back out through the call chain up back to the browser. Now, there are some important things to remember as we begin to compare how ASP 3.0 worked with ASP.NET and how it made a drastic improvement. First of all, each time the page was requested, it had to be loaded, parsed, interpreted as language, interpreted, and then actually the logic performed, and then the result was returned back to IIS and out to the web client. Also, since it's script and not a DLL, and it basically wasn't optimized for a specific machine configuration. So if you ran IIS on one machine, it would perform it and run the code exactly the same way on a different machine, even though their architectures might be different. So it didn't take advantage of any of the inherent architectures that were built into some higher-end servers. And if you wanted optimized business code, the middle tier, you wrote a COM component and remoted it. In theory, you would take that component, put it on a different machine, and then make calls out to that other machine that basically only served up these COM components. That was known as MTS or COM Plus later. And in theory, this was a faster way because you can offload some of the processing to a different machine. Of course, as higher volume sites began to test this model, it was proved that this was not the correct way to do it. In fact, as it turned out, putting the components on the same machine, the same server as IIS is actually better, although you have people fight you to the death to actually that actually don't believe that. But at any rate, that's not the point here. And then finally, the thing about ASP 3.0 was that it wasn't very extensible. So if you wanted to kind of, across all of your web pages, perform a particular function, maybe it was security, or maybe it was some type of caching, or some type of authorization service or authentication, you'd have to create another ISAPI extension to kind of filter through, or ISAPI filter, I'm sorry, to filter through and do things before the request was passed on to the ASP DLL. But this is not the case with ASP.NET. Now, when an HTTP request comes in with ASP.NET, it still goes through IIS, and it still looks in the metabase to find out which ISAPI interface should handle this request. And instead of loading the ASP DLL, it loads the ASP.NET version of that, the ASP ISAPI DLL, which then runs the .NET runtime. And then a bunch of things happen from that point on. First of all, the first pass through, it notices that your component or your page has not been turned into an assembly, so it compiles your page into an assembly. And then it just in time compiles the assembly specifically for your computer's configuration. So if you have special hardware or special processor that has optimization features, the just-in-time compilation compiles it into machine code that knows how to take advantage of those benefits built into your computer's processor, the amount of memory, and all kinds of factors like that. And then it runs the request through the HTTP modules. And HTTP modules are things that you can create. They're simple .NET applications that receive the stream of information that is passed through IIS down the call chain and allows you to do different things. And remember how we were talking a moment ago how classic ASP doesn't allow you to do things like authentication or caching or authorization on a custom basis, how you'd have to create an ISAPI filter in order to do those kinds of things. Well, HTTP modules are sort of like ISAPI filters, except that you can create them with any .NET language. And to configure them, all you got to do is make some changes to your web.config. Someday in the future, we'll do a video on HTTP modules, how to create them, what they're used for, and so on. But then you come to the HTTP handler, and that actually is responsible for invoking this new assembly that was created in the first step. And your page is turned into an assembly, and all of its methods are turned into methods of a class that's called your page, whatever your page name is, _ASPX. And your page _ASPX is derived from system.web.ui.page. So your page automatically pulls from all of the, inherits from the framework classes, and you can easily call any of the framework classes functions from your page. It's just inherent to your page. And then finally, the page completes whatever processing logic that it has and passes the resulting information formatted into an HTML page back up through the call chain and returned back for transfer to the client. So some of the most important things to remember about ASP.NET in comparison to classic ASP is that the page is compiled into an intermediate assembly, intermediate language assembly, IL, the first time that the page is called. So we'll take a look at some IL in just a moment. But the assembly is then just-in-time compiled, or rather JITted, into machine language specific to that computer's configuration. So the really big benefit here is that your page is not interpreted every single time that it's called. It's actually compiled into a DLL, and the HTML that's in your page actually gets compiled into that DLL, and I'll prove that to you in just a moment as we'll look at the IL disassembler, ILDASM, and we'll inspect the page that we create. And also, the third point is that all the HTML, the business code, it all winds up as the same thing, compiled code that's managed by the .NET runtime. So there's a lot of misconception about how to package your components, what tier do they belong on, where do you package your ASP pages, the code behind. There's a lot of confusion there. And I guess what I'm trying to tell you is that, at least initially here, that really doesn't matter because you're going to probably take advantage of a lot of the features of caching, and you're going to take advantage of all of this compiled code. And really a lot of the things that you did in classic ASP were workarounds because the model just didn't support a very robust way of calling business logic. Hope I made sense with that. And then finally, it's extensible, or rather, as it's also known, it has a pluggable architecture. So you can create HTTP modules that will filter through both coming from IIS to the HTTP handler, and then from the HTTP handler back to IIS. You can filter through the results there and do different kinds of things, and we noted just a few examples of like authentication, authorization, caching, but there's a ton of different ways you can monitor using that approach. You can add some HTML to every request that comes through, whatever your imagination can wind up with. But then also you can override the HTTP handler and choose to handle your ASPX pages the way you want to handle them. So if you wanted to just rewrite basically how the HTTP handler works, and you're going to take care of all that goes on behind the scenes, it'd be quite a task, but it's definitely possible with this architecture. So I really ran through these points very quickly, and some of them will need a lot more explanation. And I would encourage you to read through the help that comes with Visual Studio and the .NET Framework, and to get more details about what actually goes on behind the scenes whenever your ASP.NET page is requested the first time. And I believe there's some good articles on MSDN that do the same thing. I'll see if I can find some. But at any rate now, we'll go to the next part of this video. So now I'm going to demonstrate how the .NET Runtime creates assemblies from your dynamic pages. So the first thing I'm going to do is open up Windows Explorer. I'm going to navigate to my C drive, inetpub, www.root, and I'm going to create a new folder called sample. And what I'll do in that is select properties, and we'll go to web sharing and share this folder as sample. All right, now it's a virtual directory on IIS. The next thing I'm going to do is go ahead and create a page which I'm going to call sample.aspx, and I've already taken the liberty of doing this. I need to save it in a new location. But essentially it's a very simple ASPX page. The first part is the page directive where we specify the language as C#. That's important. It'll default to VB.NET. Give it a simple HTML and body control, and then we're going to iterate 5 times through the following statement. Basically, hello world, increasing the font size each time that we do it. So let me go ahead and save this into our sample directory. And now what we'll do is bring up our web browser, and we're going to run this web page for the first time. And what would you expect to happen here? We've gone ahead and kicked it off, and it took a little while to run. And the reason it did, why there was a slight delay, was because of the just-in-time compilation like we talked about earlier in the video. But now every subsequent request to that page is immediate. Here, let me bring this up so you can see in the status bar here below how fast it reloads. Why? Because it's compiled now. So just for fun, let's take a look at this a little bit deeper. What we're going to do is open up a utility that comes with Visual Studio.NET called ILDASM. And what we'll do is navigate to it by going to the program files, Visual Studio.NET, the Framework SDK, bin directory, and we'll find a program called ILDASM. So I'm going to double-click that, and it brings up the ILDASM application. And what ILDASM does is that it's a disassembler. So it takes apart the .NET assembly and allows us to look at the intermediate language, or in other words, the IL, that made up that assembly. So it won't look like C# or VB.NET. It's the language that VB.NET, C#, and all .NET languages get compiled to and placed inside of the assembly. So what we'll do is we'll click File, Open, and now we have to find where did .NET create the assembly for the web page we just looked at. And what we'll do is go to our C drive, Windows, Microsoft.NET, Framework. We'll look at the version that we have, temporary ASP.NET files, sample some numbers that indicate something, not quite sure of, and again, and we find our assembly. So let's go ahead and open that. So the first thing that you'll notice here is that there's a little road sign that indicates a namespace. And when our page is compiled, it's compiled into a underscore ASP namespace. That's default for all ASPX pages that we'll create. And we can see here that this class name is sample underscore ASPX. It's named exactly like our page, except it replaces the underscore for the period. So let's go ahead and expand this and take a look. The first thing that I want you to see is this extend statement, that this class extends, or rather inherits from, system.web.ui.page. So quite literally, our page becomes a new object in the .NET runtime. The next thing that I want you to take a look at is this render control. We're going to double click that to bring up the actual IL for that method. So this intermediate language is what actually gets compiled when you create an assembly before it's JITted by the .NET runtime. Now, one of the things that's interesting here is notice there's HTML, there's a body tag. Notice here that you have the P and the font size equals, and then you see a bunch of these text writers that write out a string, an instance of whatever was looped through. So there's a looping that goes on here, and there's this value of I that we use to increase the size of the font. And then again here, we see hello world. So there's the actual HTML. Now, does that impress you that whenever you create a .NET assembly from your ASP.NET pages, what's actually happening is that HTML is getting compiled into the DLL. Can you think of the practical advantage of that? Of course, it's going to be faster. It's different than ASP 3.0, where every time the page ran, it had to be interpreted by IIS. This is different. It's compiled right into a DLL. It's loaded into memory once, it's created once, and then it never has to reinterpret that information again. It's very quick in that regard. And whenever there's something written out to the response stream, it's basically by using these text writers doing a response.write. So even though we opened up Notepad and it looks just like you're scripting out a page like you did in ASP 3.0, actually ASP.NET is parsing it and turning it into assembly. It instantiates the class and calls it to render the page. So after the first call of the page, it doesn't use the ASPX page at all anymore. It simply instantiates that DLL and calls it to render the page. So there's a dramatic performance improvement as a result of this in ASP.NET. Well, that pretty much wraps up this video. We looked at how ASP.NET differs from ASP 3.0 and what the performance improvements were and why that is. We actually looked at some IL and noticed that, as just a moment ago, how the HTML that's rendered is actually compiled right into the assembly, and why there's a performance improvement as a result. So I hope you enjoyed this video and learned a little bit more about how ASP.NET works. Thank you.